right, welcome back to lesson 14. This is part 2 of lesson 14. And so now we're going to kind of shift gears a little bit and talk about yet another vocab word. And that word is proportion, which I know you have all heard of. A proportion. I know you've solved these before in the past, but proportions still have to do with ratios. You'll see in the definition of a proportion is two ratios set equal to each other. Set equal to each other. Okay, there we go. A proportion is two ratios set equal to each other. So because they are set equal to each other, that means that technically all proportions are equations. They are. Every proportion is considered an equation. And so if you like solving equations, you probably will like proportions. I personally love doing these. These are a lot of fun to me. If you like equations, yes, you should like these. If not, I apologize, but hopefully you still kind of like them. They're not real nasty. Like you're never going to see a proportion that takes 6 steps to do. So that's good. As a matter of fact, let me show you an example of what a proportion would look like that's already solved, if you want to think of it that way. This one is 5/6 equals 10/12. All right, so right there, this example that I gave you is a proportion. There's an equal sign in between two ratios. Two ratios set equal to each other. And hopefully you guys can all tell from looking at this that this is a true proportion. True proportion means that and we'll talk about the technical definition in a minute, but a true proportion means that the ratios really are equal to each other. And so you guys know if you multiply the top and bottom here by 2, what do we get? Well, 5 times 2 is 10, 6 times 2 is 12, so you get 10/12. So they are actually the same exact fraction, just written in a little bit of a different form. So this would be considered a true proportion. Now, there's a couple things to note here, how to pronounce this, or how to say this, I should say. 5 is to 6 as 10 is to 12. Put that in quotes there. Okay, so there we go. So that's really how you would say this. You would say this proportion means 5 is to 6 as 10 is to 12. That's one way to say it. Now, don't worry too much about that. Don't get too hung up on that. That's not something you're going to have to recite back on my math lab or anything. But I just wanted you to understand what this means in words. All right, so let's write down now how to determine if a proportion is true. To determine if a proportion is true. Okay, because a proportion can be true or false. So to determine if a proportion is true, you're going to multiply the diagonals. You're going to multiply the diagonals. That's really all you have to do. If the cross products, that just means if the results you get when you multiply each diagonal are equal, okay, if the two numbers you get are equal, the proportion is true. The proportion is true. If not equal, then false. Okay, pretty self-explanatory, that last sentence probably, right? If not equal, then false. Okay, if they're not equal, then false. So again, what you're going to do for all of these types of problems where they ask you, are the proportions true or false? All you have to do is multiply the diagonals. And if the results you get are the same two numbers, then you say true. But if not, that's when you say false. Let's look back up here at our example. I gave you an example of a true proportion. Let's go ahead and just very quickly in our heads multiply the diagonals. So right here, what's 5 times 12? 5 times 12 is 60. Okay, remember that number, 60. Now let's do the other diagonal. What's 6 times 10? Also 60. So you get 60 and 60, and since you got the same result, then you say, yes, this is a true proportion. But if you would have gotten different numbers, it would have been a false proportion. Okay, so here's the question that you're going to see in my math lab. Are the following true proportions? All right, are the following true proportions? All right, here is example number 1. How about 2/3 equals 34/51s? Okay, so sometimes the numbers are high and you can't really do them too easily in your head. And so again, a calculator is going to be very handy for doing this. So what you want to do is either in your head or on the calculator or by hand, however you want to do it, you want to multiply each diagonal. And it doesn't matter which one you start with, by the way. You could do the 2 times the 51 first, or you could do the 3 times the 34. That does not make any difference. So let's just go ahead and do these two first. Really doesn't matter. So 3 times 34, I'm just showing a little bit of work here so you can see it. 3 times 34 is 102. Okay, I already did this on my calculator. You could also do it by hand. And then let's do the other diagonal, 2 times 51. So then 2 times 51. If you type that in your calculator or do that by hand as well, you're also going to get 102. So you get 102, 102. So since those are the same number right there, is this a true proportion? Yes. Okay, the question is, are they true? So your answers are going to be yes or no. Okay, so there you go. So you say yes. All right, let's try example 2. All right, what about something with a decimal in it? A couple decimals in it, that's okay. 4.1 over 7 equals 2.9 over 5. So something like this. Again, if I were you guys, I would just probably take a calculator and do this. But we did talk about it in one of our recent lessons, how to multiply decimals by hand. So feel free to look at your notes on that if you forgot, and feel free to try it. But I'm just for the sake of time, going to just assume we're all using a calculator here. So 7 times 2.9 is 20.3. Okay, so you get 20.3 when you multiply those two. And then the other diagonal, 4.1 times 5. Okay, 4.1 times 5 or 5 times 4.1, same thing. You get 20.5 when you multiply those two. Okay, so you have a 20.3, a 20.5. Did we get the same result? No, we did not. Those are not the same result. I'll just put an X by them. And so then our answer, of course, would be no. These are not true proportions. Okay, great. So far, I hope you would agree with me. So far, it's pretty easy, right? Just multiplying those diagonals, seeing if the numbers are the same. It is about to get a little tougher, but still not bad, especially if you have a calculator with a fraction key on it. You'll see what I mean here in just a second. So let's write down example 3. Example 3 looks like this. We have a bunch of mixed numbers now. 1 1/6 over 10 1/2 equals 1/2 over 4 1/2. 4 1/2. Okay, so we have this type of situation now. Okay, so we have a lot going on here. You could just take your calculator and do 1 ABC 1 ABC 6 and then times this one, 4 ABC 1 ABC 2, and you would get a number there. And then you could do that again, 10 ABC 1 ABC 2 times 1 ABC 2 equals, and you'd get a number there, and you could compare them, and that's all you have to do. So if you're using a calculator, you could totally do that. Or if you're doing it by hand, what you want to do is convert any of these that are not not fractions, not improper or proper fractions. You want to convert them into those. You want to get them out of this mixed number form. So we've done a lot of that, but I guess I'll do that real quick with you guys by hand just this one time. So let me go ahead and do these two. We'll multiply 1 1/6 times 4 1/2. Okay, so if we're multiplying those two diagonal numbers there, this turns into 6 times 1 plus 7. I'm sorry, 6 times 1 plus 1 is 7. So you get 7/6 times 4 times 2 is 8 plus 1, 9 halves. So that's what it looks like when you convert them into improper fractions. And then of course, you can go ahead and simplify, or you can multiply straight across and then simplify. I'm gonna go ahead and take a 3 out of these two, take a 3 out of those two, so it turns into 7 over 6 divided by 3 is 2, equals 9 divided by 3 is 3 over 2, and then I'll multiply straight across the top and bottom, so I get 21 over 4. 21 over 4. Okay, so that's that one. And then I'm going to go ahead and do my other diagonal, 10½ times 1/2. Okay, so we're going to do this one now. Okay, so this one turns into 2 times 10 is 20 plus 1, 21 over 2 times the 1/2 is already in proper fraction form, which is really nice. And so now there's nothing I can do to cross simplify. So I'm just going to go ahead and multiply straight across the top and bottom. 21 times 1 is 21. 2 times 2 on the bottom is 4. So look what I have here. 21 over 4. 21 over 4. I got the same number. So am I going to write yes or no here? I'm going to write yes. This is a true proportion. We got the same result by multiplying the diagonals. Again, if I were you guys, I would just use a calculator here. Way easier, way faster. But I just wanted to show you that it can be done by hand using fractions, and it's not that terrible. All right, so there's going to be 2 parts to the proportion stuff in your homework and on the quiz. We just finished the first part right here where you have to say yes or no. Is it a true proportion? Yes or no. Now the second part, the last part, is where you have to actually solve, just like you're solving an equation. So let's write this down. To solve for x, or really any letter, it could be an n. I think my math lab uses n kind of a lot in these. So to solve for x or any variable in a proportion, maybe I'll put x in quotes because it doesn't have to be x. It can be any variable. To solve for x in a proportion, set the cross products. Set the cross products. That just means multiply the diagonals, set them equal to each other, and then solve. Okay? So to solve for any variable in a proportion, you're going to set the cross products equal to each other and solve. So pretty much what you're going to see in the directions for this chunk in your My Math Lab assignment is it's going to just say solve. So here is example number 1. You might see something like this. 2/3 equals x over 30. So we'll start off kind of easy. 2/3 equals x over 30. Notice also, guys, that the directions just said solve. It did not say anything about rounding, but occasionally you might see a problem where it says round to the nearest tenths or hundredths or 2 decimal places or 3 decimal places, whatever it says. If it tells you to round, of course, you want to do that. But if it doesn't tell you to round, then you have to write your answer as simplified as possible. It's just understood. Okay, so here we go. 2/3 equals x over 30. So what you're going to do is multiply the diagonals. So you're going to say, okay, what's 3 times x? 3 times x is 3x, right? And then you're going to say equals the other diagonal, 2 times 30. Okay, so see what we just did there? We multiplied this diagonal and we said 3 times x is 3x. And then we put an equal sign in there, and then we multiplied the other diagonal, 2 times 30, and put it right there. And so now all you have to do is solve this. This isn't that bad. So I'm going to put a little bridge there, and I'm going to say, okay, I'm going to bring my 3x down for a second. And then what is 2 times 30? That's 60, right? And then you all know how to solve this, I think, a one-step equation. To get x by itself, you got to get rid of the 3. It's 3 times x. So the opposite, of course, is division, dividing the 3. So you get x equals, what's 60 divided by 3? Then the final answer is 20. You get a 20 for your final answer. X equals 20. Okay, cool. All right, let's try a few more of those and then we'll be done. A few more examples. All right, how about example 2? Let me give you one that has a negative in it because I just want to show you that it doesn't really make it any harder. You just have to be careful and make sure that you include the negative where it needs to be. So how about this one? 57 over 38 equals negative 3 over x. Now you're probably going to notice when I set these up, I always like to do the diagonal that has the variable in it first. That's just me. You can do whatever you want, of course. It does not matter which diagonal you start with, but I always like to start with whichever diagonal has the X in it or the letter, because it just, I don't know, I just like to have that letter on the left side of the equation. But again, it really doesn't matter. So here we're going to do 57 times X, which is 57X. Then we're going to say equals, and then we're going to multiply these two. -3 times 38. And there's our equation. Okay, probably don't need that long of a bridge, but that's okay. So there we go. So now we're going to go 57x equals, and we have to figure out what is -3 times 38. So that is a -114. You could just put that in on the calculator. You get -114. And now your last step, of course, is to get x by itself. So you have to get rid of the 57. You can divide both sides by 57. It cancels over here. So you get x equals -114 divided by 57. And it just so happens that this works out to a nice answer of -2. All right, so x equals -2, final answer. Okay, let's try one with decimals. I'm just gonna try to show you like everything you could see. So how about this one? X over 3 equals 0.8 over 1.5. All right, so x over 3 equals 0.8 over 1.5. So just because these are decimals doesn't mean you have to do anything different. I still like to personally start with whichever diagonal has my variable in it. So I'm going to multiply x times 1.5. So that gives us 1.5x. And then I write equals, and then I multiply my other diagonal, 3 times 0.8. Okay, so make my bridge, bring down my 1.5x equals, and then 3 times 0.8 is actually 2.4. Okay, and again, I would just use a calculator there, or feel free to do it by hand, but 2.4. And then your final step, of course, then is to divide by 1.5. You probably noticed that there's like division at the end of every single proportion, and that will be the case. That will be your last step. So that's going to keep happening. I just want you to be aware. So when you divide 2.4 divided by 1.5, your final answer there is 1.6. Wait a minute, that's not right, is it? Hang on, something seems wrong with that. Let me just double check that. Hang on. 2.4 divided by 1.5. Oh no, that is right. It just didn't seem right to me. Okay, good. I was second guessing. Okay, so there we go. X equals 1.6, final answer. Okay, good. All right, so that's one with the decimal. All right, let's just do 2 more examples and we will be done. So I'll start a fresh page actually for these last 2. So let's just do example 4 and example 5 and we will be good. So here's example 4, and this one is, I'm gonna put a little star next to it and write hard, because this one is kind of tough, I'm gonna be honest with you. So this one is 1/2 over 4/5 equals, put a bar here, 3/4 over y. Okay, so let me read that to you again if you're having trouble seeing it. It's 1/2 divided by 4/5 equals 3/4 divided by y. So you could see a proportion like this where you have a bunch of fractions in it. That definitely makes things more difficult. All right, so when you do this, you're still gonna do it the same way. You're gonna say, okay, let's multiply the diagonal. So when you do that, you have 1/2 times y. So 1/2 y equals, and now you have to multiply these 2 fractions. 4/5 times, I'll just write it this way, you could use parentheses if you want, doesn't matter, times 3/4. Okay, so this is what you end up getting for your proportion when you multiply the diagonals. Okay, so now we're gonna bring down the 1/2 y, we'll get to him in a second, equals, and we're gonna go ahead and multiply these 2 fractions together. You could just use your calculator with the ABC key, or you could say, oh, by hand, I know I can divide a 4 out of those 2 diagonals. I'm allowed to do that. So this whole thing turns into 4 divided by 4 is 1/5 times 3 over 1. You could do it like that, and then just bring down the 1/2 y again, and then multiply straight across the top and bottom. You get 3 over 5, or 3/5. Okay, so we're really close to there, but we're not quite done. So now this is where it gets tricky, and actually this is going to have to do very heavily with our very last lesson of the entire semester. Lesson 18 covers what we're about to do in this next step, and that is this right here. You have a 1/2 times y. So you want to get y by itself. So how do you get rid of a 1/2 when it's being multiplied by y? Yes, you have to do the opposite. You have to divide by 1/2. So divide by 1/2, divide by 1/2. So that means that cancels, those 1/2s cancel. So now you have y equals, y is all by itself on the left side, which is great. But now look what you have over here. You have 3/5 divided by 1/2. We just did this a few moments ago earlier on in the part 1 of this video, where we reviewed how to handle fractions and division. You keep the first fraction the same, you change the division sign to multiplication, and you flip just the second fraction. So that one turns into 2 over 1. Instead of 1 over 2, it's now 2 over 1. And then of course, for your last step, you can go ahead and multiply straight across the top and straight across the bottom. So 3 times 2 is 6, and then 5 times 1 is 5. And so your final answer here is y equals 6/5. Notice, it did not tell us that we had to round our answer. It didn't tell us write your answer as a mixed number. It said nothing about that. If it did, you would have to follow those directions, but it did not. So all we have to do is just write our answer as a improper fraction, fully simplified, which we did, and we are good. All right, before we do our last example, we just have one last one left. I do just want to show you or point out one thing, because this seems to come up every year, every time I teach this course, because I have to say, in all of my students' defense, it is very confusing how my math lab sets up some of these questions. You'll notice here in this problem, I had fractions within fractions, right? Like especially on the left side, I had this fraction bar and I had a fraction over a fraction. And many times my students get confused and they're like, I can't tell where the bar is that separates the fractions. Let me write something down here. You do not need to copy this, but let me just show you something that my math lab has done before. They've done things like this, where they go, okay, let's just say like 1/4, and then they do this little bar, and then they go like 3/8, and then they go equals, and there might be like a y here, and then like a bar, and then like maybe like a 4 right there, something like that. Something like this really confuses my students a lot. They're like, I don't even know how to do this because I can't read it. I don't really understand where the fraction bar is that separates. And here's what I tell my students. And sometimes even these bars are longer. Sometimes they even go like this, and that really drives me crazy. So here's what I tell them. I say, look at the equal sign. It's all about the equal sign. Because if you can find the equal sign, then what you want to do is look directly to the left and directly to the right. Those fraction bars are the fraction bars that separate your top from your bottom when you are trying to multiply diagonals. So you want to, again, look at the equal sign, and then look at the fraction bars right next to the equal sign. Maybe even circle them if you're going to rewrite the problem. And then maybe that'll be a little clearer to you on how you're supposed to multiply the diagonals. So in this little example I just gave you, it would be like these would be multiplied, right? So it would be 3/8 y equals, and then it would be 1/4 times 4. Okay, hopefully you can all see that. I hope you can all see that. Maybe I'll put that in parentheses, doesn't really matter. I hope you can kind of see what's happening. If you have any trouble at all, please email me, because I know this kind of trips people up sometimes. But again, my best advice to you would be look at the equal sign, just like in this example up here. Look at the equal sign, and you can say, okay, well, here's my fraction bar to the right. Here's my fraction bar to the left. Those are my main fraction bars. So anything above it gets multiplied with anything below it over here. And then anything above this one gets multiplied by anything below this one. Okay, so kind of look for that equal sign. That's the best advice I can give you. Hopefully that helps. Even though sometimes they make the fraction bars really short, really small, they don't make them real long. I don't know why they do that. That gets even more confusing. But again, look at the location. Look at the left and the right of the equal sign. All right, here's the last one I'm going to do with you guys. Let's do this one. And this one might seem kind of easy. It's like, well, why did you save this one for last? Number 4 was clearly the hardest one. I just want to give you one last example, and I want to show you one where you have to simplify at the end and where we do not want to round, even though it's tempting because your calculator might give you a decimal. You do not want to do that. So here's our last example. 14 over x equals 12 over 16. So let's go ahead and I'll start with this one. 12 times x is 12x equals 14 times 16. So we're going to go like that, make our fraction bar there. And so I'll bring my 12x down, equals 14 times 16 is the number 224. Again, using a calculator is probably ideal, 224. And then your last step, of course, is to divide by 12. So you get x equals 224 divided by 12. Now, ordinarily, that would be your answer if it was fully simplified, but it's not. There is something you can divide out of the top and bottom. In fact, the highest number you can divide out of the top and bottom is a 4. Okay, you can't go any higher than that, so we might as well just do that. 224 divided by 4 is 56. Over 12 divided by 4 is 3. And so that is your final answer now. So in this one, we did have to simplify at the end. We got 56 over 3. And again, I know it's tempting, like some of you in your calculator, you might have, like on this step way up here, you might have typed in 224 divided by 12, and then you got like, you got some sort of decimal, right? You got a decimal there. But we don't want to do that. Only write a decimal if the directions tell you to, and they will sometimes. So just be on the lookout for that, but don't do it if they don't tell you to. All right, that concludes lesson 14. That also happens to conclude our last lengthy lesson. The remaining 3 lessons that we have for this course are all significantly shorter, which is great news. So we are now done with all of the really long lessons. We are almost done with everything we need to learn for this course. So you guys should be super proud. You have done so well. All right, I'm gonna end this video and I will load it to YouTube and get them posted. All right, see you guys soon.